Have you ever found yourself just tangled in a massive web of if-else statements? You're trying to figure out which little piece of your code is supposed to handle some request. Well, today we are going to untangle that knot with a really powerful behavioral pattern, the chain of responsibility. I mean, think about it. In any system we build, requests are flying all over the place. HTTP calls, user commands, you name it. And the big question is always the same. Who's actually supposed to deal with this? Okay, let's use a super relatable example, a customer support system. A simple password reset? Yeah, level 1 support can handle that, no problem. But what about a major system-wide crash? That has to get escalated, right? If you try to manage all that with a giant block of if-else logic, well, it just becomes a total nightmare to maintain. So what's the alternative? Well, the elegant solution is to stop playing traffic cop. Seriously. Instead of you routing the request, you forge a chain of potential handlers, and you let the request find its own way. It just gets passed from one link to the next until it finds a home. And this brings us to the official definition. The chain of responsibility pattern lets a request get passed along a line of handlers until one of them finally takes care of it. Now, the key here, and this is super important, is that the sender doesn't know, and frankly doesn't care, which specific handler will process the request. This loose coupling is what makes the whole system so incredibly flexible and easy to maintain. So let's actually build this out with our support ticket example. A new request comes in, let's say it's for a software installation. It immediately gets sent to the very first link in our chain, Level 1 support. Now here's the critical decision point. Level 1 support looks at the request and goes, no, not for me. But instead of just rejecting it, it simply passes the exact same request on to the next handler in the chain, which is Level 2 support. And you know what? Level 2 might look at it and pass it on too. But when the request finally hits Level 3, that team recognizes it, they take action, and boom. Once the request is handled, it stops traveling down the chain. The process is complete. It's a perfect illustration of how this pattern works. So how do we actually build one of these chains? Well, the structure is surprisingly simple. It really just relies on 3 key players. Let's break them down. First up, you have the handler interface. Think of this as the blueprint, or the job description, that every single link in the chain has to follow. Second, you've got the concrete handlers. These are our Level 1, 2, and 3 support teams. They're the specialists who actually do the work. And finally, you have the client. This is the part of your code that kicks off the request, but it only needs to know about the very first handler in the chain. That's it. Now, it's pretty easy to confuse this with the decorator pattern because, they both use a chain of objects, but their goals are completely different. With chain of responsibility, the goal is for one single handler to eventually process the request. With the decorator pattern, every single object in the chain gets a chance to add its own behavior. Totally different outcomes. All right, so like any design pattern, this is not a silver bullet. It has some absolutely fantastic strengths, but there are also a few things you gotta watch out for. Okay, the biggest win here by far is decoupling your sender and receiver. This gives you incredible flexibility. You can add, remove, or even reorder handlers on the fly without breaking your client code. It's amazing. On the flip side, debugging can get a little tricky since you don't immediately know which handler took care of the request. And you also have to be really careful that your chain is set up right, otherwise a request could fall through the cracks and never get handled at all. So, with those trade-offs in mind, what is the big takeaway? Why should you add this powerful pattern to your personal toolbox? Really, it all comes down to these 3 things. First, decoupling. It just cleanly separates the thing that sends a request from all the things that might process it. Second, flexibility. Need a new level of support? Just create a new handler and slot it right into the chain. You don't have to rewrite the client. And third, simplicity. The client's job becomes dead simple. Just send the request to the start of the chain and trust that it's going to get handled. As the folks at Geeks for Geeks put it, it's a powerful tool for creating a flexible and extensible system. And that's what we're all after, right? Building software that's easier to change and grow over time. So that leaves us with one last thought. The next time you find yourself writing a super complex set of conditional checks to handle different kinds of requests, just take a second and ask yourself, where could this pattern untangle the complexity in my code? Thanks for joining me.